All right, thank you so much for joining us today. My name is Andrew Burt. I am managing partner at bnh.ai, a boutique law firm focused on AI and analytics. I'm joined by Patrick Hall, principal scientist, and we are going to talk about the liabilities and how to manage them. Basically, what can go wrong and what to do about it in the world of NLP. So with that, I'll get started. Basically, with this headline, I think this is fairly indicative of where many companies and organizations are in the market right now. This is a headline from Harvard Business Review a few years ago, basically stating that if you, as an organization, if you haven't adopted AI, you're frankly too late. Things are moving so fast, and AI is such a powerful, transformative technology. There's really just been this widespread rush to adopt it. And we are believers in AI and machine learning, which for today I'm going to kind of use synonymously. So forgive me for that. But we're big believers in the technology. There are many things it can do, NLP in particular, but there are all sorts of risks and liabilities that can emerge. And that's really what we want to focus on. And so this is true for AI in general, but we think it's even more true for NLP. And so here are just a few examples of all the things that can go wrong as I kind of fill up the screen here. And the truth is that there are many, many different ways, specifically relevant to natural language processing, that these types of models can cause real harm and can cause real and serious liabilities for companies and organizations that are deploying them. And so at the same time, that, you know, the hype is real. There's a lot that we can do with this transformative technology. There are also really, really serious risks, which brings us to this question. Basically, how can we prepare AI for practical adoption in the real world, in real world operational environments, when there are all of these harms, security harms, privacy harms? A lot of the headlines that we just ran through were specifically focused on discrimination. So what can we do? And from our perspective, there are really two major barriers that stand in the way of deployment in real world scenarios. And if they don't stand in the way, they can generate serious liabilities and cause major problems and harms. And on the one hand, there are legal liabilities, and on the other hand, there are technical challenges. And what we at bnh.ai have seen firsthand over the years is that these two areas are very, very hard, if not nearly impossible, for any one team to confront on their own. And frankly, in practice, what we see a lot is that the legal departments and the risk and compliance departments that are focused on what could go wrong have a hard time communicating with the technical and the data science folks who are actually building the models, and vice versa. And so there's this kind of barrier that really needs to be transcended. And that's what we are focused on as a law firm, and it's what we're focused on today. So the plan for the rest of this presentation is I'm going to talk about the legal liabilities, some guidance on how data scientists and even lawyers might want to think about these in practice, and then I'll turn it over to Patrick, who'll walk through some of the technical challenges and then explain kind of how we can, as a community, legal, data science, and more, come together and address these challenges. So to start with, I think it's fairly kind of intuitive and well known that more laws and regulations are coming on AI. It seems like almost every week there's a new or proposed regulation. Here are a few just kind of examples. The Algorithmic Accountability Act from last year was introduced in both the Senate and the House. I point folks to that, but we see kind of broad regulations. We see regulations in municipalities, like the facial recognition ban, bans that we're seeing. And then we also see sector-specific regulations. So I think there's kind of a widespread recognition that the more we use AI into the future, the more regulated it will be. But that being said, even without new laws and regulations focused on AI, there are a host of legal liabilities stemming from laws just today that I think AI practitioners and NLP folks in particular in the NLP community should be focused on. And so this is a very high level overview of the kind of 7 main buckets of liability, legal liability, that we see in the world of AI. And so I'll just kind of go through this relatively quickly. So I think, you know, the first 3 bullets here are relatively intuitive, fairness, it's incredibly easy, all too easy for AI and NLP models to discriminate. Privacy and security harms, I think both are fairly intuitive. Interpretability, this is a growing issue. There are some regulatory environments already today, credit environments and finance in the US, to some extent GDPR in the EU, that require models to explain themselves, to explain their inner workings. Agency, some models actually act on behalf of their developers once deployed. I think this is a particular risk for chatbots. You can end up deploying a chatbot and having it make a recommendation, or having a consumer rely on that chatbot in ways that are unintended that can give rise to all sorts of harm. Third parties, it's very rare in practice that we see any one particular model deployed by one single party that owns or has collected all the data. It's in charge of training and architecture selection, deployment, auditing, infrastructure. And so it's very easy for different third parties to share different levels of liability and risk. And so this is a problem, frankly, that we see getting more and more complicated by the day. And then lastly is just negligence. There are reasonable standards of care in designing and deploying some of these models. And if they go wrong, if they cause harm or discriminate, there can be just kind of traditional liability under negligence. So those are kind of the 7 buckets. That being said, we're looking really closely at the FTC, which starting frankly in January, the Federal Trade Commission, starting this year, the commissioner gave this really big speech that basically said, we're coming for AI, that AI, and in particular, algorithmic discrimination is a huge and a growing harm, and the FTC is going to be increasing its oversight. And so in April, just frankly at the beginning of the quarantine, the FTC released this note on its website, basically analyzing all of the different ways that organizations could face increased liability using AI. And so I'll walk through some of this analysis before turning it over to Patrick to talk about kind of the same issues, but from a technical perspective. So basically, we've broken things down into 6 questions that the FTC and I think other organizations or other regulators might ask in the future of data scientists. And so I think the first is there any view under which the model is being used in something like a credit decision, a relatively high stakes environment for something like credit, employment, insurance, housing, or any analogous benefits and transactions. And in the US in particular, any decision that kind of falls under that rubric or data that's furnished for that type of decision has increased oversight and increased liability. And I think really importantly for the NLP community is that this can include chatbots specifically. So there are lots of circumstances under which chatbots might be used in this context and therefore give rise to higher vulnerabilities, higher liabilities. So speaking of vulnerabilities, the next is security. Basically, has the model and the data associated with it been secured according to reasonable standards? I think in plain English, the real question is, can you demonstrate that there were clear efforts to secure it, like documentation and auditing? And then privacy, which is basically, this is kind of a complex world, but in a nutshell, it's is the data that's being used in your models, is all of that data, is all that use clearly aligned to privacy policies and other related privacy regulation? So credit decisions, security, and privacy, all of this is, I think, relatively intuitive. Credit decisions, maybe a little less so. The last 3 questions here from the FTC, I think misrepresentation, number 4 here, I think this is really interesting. They're basically signaling that there are certain environments where AI might kind of cause the deceptive, be deceptive in some way, and making a consumer think that they're not actually interacting with an algorithm. And so this is an area that they're signaling could lead to increased liability. I think this is especially kind of a problem with chatbots, which are used in many circumstances to mimic kind of human language interactions. Sensitive data, is the data being used either to train or actual the production environment for the model? Is that data sensitive in any way? Does it contain biometric or health information or other types of PII? And I think accountability. And this, I think, is a really interesting question, because basically in the absence of clear standards for what it means to secure AI, and in the absence of clear standards for what AI assurance really is, all these standards, I think, are very much in development. Regulators are basically asking, can you just prove as an organization that you have tried to be accountable? And so one of the things that they're looking for, kind of like a measuring stick, is, has a third party or some group that is not the actual kind of frontline model developers, have they been involved in red teaming or assessing this model for potential vulnerabilities or liabilities? And so I think this is a really important point. I think this accountability point is really only going to get more important in terms of minimizing liabilities, both from a regulatory perspective, so like not having regulators come after you, and also just in terms of avoiding harms, identifying and avoiding harms before they occur. So that is a very quick overview of the liability landscape for AI and NLP in particular. And I will now turn it over to Patrick.
Sure. So thanks for that crash course, Andrew. And I'm about to give a crash course in sort of the technical side of things. And, you know, I'll just spend a few seconds on this slide re-emphasizing that, you know, AI is a fairly high-risk technology, given, you know, what Andrew just talked about and what I'm about to talk about. And one of the best ways to mitigate risk is just to have different kinds of people involved in the project, right? And I'm speaking both demographically and about professional backgrounds. And so while Andrew was able to give you the sort of legal rundown, I'm going to try to give you the technical rundown. And I think that's just a good example of one type of bringing professional diversity into AI projects. So just want to reemphasize that, and we can jump to the next slide. Okay, so probably a lot of people watching know what these technical challenges are. So I'll try to be quick here, but I'll try to highlight them in ways that maybe from a policy or legal perspective, perhaps some in the audience haven't really thought about them before. So we know that machine learning models, particularly complex new NLP models, can be very opaque. They can be very, very difficult to understand how they work. And this is a problem for several reasons. I mean, Andrew just said there are places in the U.S. economy today where you have to explain your model, you know, by regulation. We expect those kinds of regulations to increase in the future. There are places in the U.S. economy today where you have to document your models very thoroughly, and that can be difficult if it's a black box. And again, we expect those regulations to expand out of financial services and into the broader economy. Perhaps the most important reason, though, that models need to be explainable is so that humans can interact, and in particular appeal and override model decisions. And there have been numerous headlines recently about AI or ML algorithmic systems sort of making decisions for people and having there be no appeal process for those decisions. And in general, that's just a bad idea. And interpretability and explainability are ways to enable sort of these appeal and override capabilities, which can stop, you know, the bad thing, the AI incident from happening. Andrew introduced this idea of security and privacy vulnerabilities. There are ways for your model to run afoul of privacy law, privacy policy, reasonable security standards today. And sort of on the tech side of this, some of these attacks have been published for years now. And so, you know, things like model extraction attacks, and in fact, there was a headline about that on the first slide of AI incidents, where from the Clever Hans blog, talking about stealing a model with gibberish. So these attacks have been out there for a long time, and just simply ignoring them is probably not a good idea, both from a legal and technical perspective. And of course, you know, the privacy issue is huge, right? We're oftentimes training these models on sensitive data that could run afoul of any, you know, GDPR, CCPA, company privacy policies. So this is a big one. Of course, discrimination, right? A lot of those headlines on the introductory AI incident slide were about discrimination. And this is a particularly vexing problem in NLP. I mean, reading about the new GPT-3 model, it did appear that the developers tried to do some discrimination testing, but data scientists and policy people tie themselves in knots on how to test discrimination in a simple binary classifier. What in the world are we going to do with something like GPT-3 that can, generate all kinds of data that can be potentially discriminatory? How can we even test that, right? And I think that's something that the developers of NLP systems need to think about from the beginning of their development process, right? How can I test this very complex system for discrimination, knowing that testing a simple regression or simple classification model is already difficult enough? We like to highlight this idea of differential validity, which is an idea that comes, I believe, from employment law originally. And I could be wrong on that. I'm not a lawyer, so Andrew, feel free to jump in and correct me on any of the law stuff. So differential validity is this idea that the model would be less accurate for different groups of people, different demographic groups of people. So we're oftentimes or getting used to, sadly, hearing about discrimination in terms of a model's outcome. Less people in this one demographic group got the loan. But another kind of discrimination that we're trying to draw people's attention to is the idea that the model would be less accurate for certain groups of people. And that ends up causing just another kind of discrimination that can be equally, if not more, damaging. So, all of these things on their own are complex and hard to deal with, but the reality is they're intersectional phenomenon, right? And so I think Kay, who we always pick on, the top picture on the slide that you're seeing, that's the famous Microsoft Research Twitter chat bot that was poisoned by Twitter users to essentially become a neo-Nazi, right? And this is another issue with these complex sort of NLP models, right? There was no code in Tay that said, hey, go be a neo-Nazi. The data inputs to the system changed and the output of the system changed, right? And so you can think of this as both sort of a security problem, right? People were able to poison the training data, alter the outcome of the model, but it's also a discrimination problem. And that's what I mean when I say these problems are intersectional, right? Things can easily be security problems, discrimination problems, privacy problems, discrimination problems at the same time. And that's just a very challenging thing. Down at the bottom, we have the famous picture from some of the original sort of term embedding research. And I was deep in this back at the time when this came out. I just remember being so excited. This idea of being able to do vector arithmetic with term embeddings was mind-blowing. And now I look at the same graph and it makes me nervous because I know when I see things like this, if you dig just a little bit deeper, very likely that the model's encoded some kind of very unfortunate sort of pre-existing gender biases into itself. So funny how things change over just the course of a few years. But let's go ahead and go to the next slide. But Andrew, please feel free to chime in. So how do these risks that I just went over, boots on the ground, how do they translate into a data scientist's life? Well, we've developed these questions that are fairly pointed and specific, and hopefully they'd help you think through this in your own work. So, are there outcomes, so starting at the top with fairness, are there differences in outcome or accuracy across different demographic groups in your model, right? And then point two there is, can you even evaluate this? And if you can't evaluate it, I mean, I think especially in a commercial setting, you should really, maybe go back to square one and really consider what you're doing. Of course, privacy. So different privacy regulations and privacy policies have different characteristics, of course, but the big ones tend to be around user consent, data anonymization, and how long or how long you must store data. How long are you able to store data? How long must you store data? When do you have to destroy it? And of course, a complex machine learning system hungry for data could touch on any of these issues, right? Have the people who are in the training data consented? Is the information sensitive? Should it have been anonymized? Were you even allowed to use the data? Was the data already supposed to be destroyed at this point? And so those are sort of the questions for privacy. For security, you know, FTC publishes reasonable security standards, right? And those apply to all software. I mean, your machine learning system is just a software system. So did you use best practices like access control to the data, authentication, this idea of least privilege, where, you know, just because you're a rock star data scientist doesn't mean you get access to every single thing in a giant company's IT system. So you want to limit the amount of permissions that people have across an IT system. Sorry, even for rockstar data engineers and data scientists. And then this gets to the black box issue that we'll touch on again when we talk about interpretability next. But can you even know if a breach occurred? Can you know if there's been an adversarial attack on your machine learning system where someone may have stolen your model logic or your training data? Can you even know that? And again, that would be one of those head scratchers where you may need to go back to sort of step one and rethink things. Interpretability, we've sort of harped on this enough, I think, and I think people get it. You know, these complex models are black boxes. Again, there may be spaces today that your model could be used in where you have to generate an explanation, and can you do that? Can you adequately document your black box system? And I was chuckling to myself today looking at the GPT-2 model card. You know, a model called, at one point called Too Dangerous to Release, had a 2-page model card. You know, oh, I feel better now. So the idea of model cards, I think, are convenient and a good advance, but I think, you know, for something as complex and as important as GPT-2, GPT-3, that's really just the bare minimum. And I'll reemphasize, I'm not a lawyer, and I find these agency and negligence concepts tricky, and so Andrew, please feel free to jump in if I mess them up. But really, with agency, we're talking about, and I think this really rings true for me for chatbots. Did your machine learning system agree to something on your behalf without authorization? Essentially, agreeing to something that they shouldn't have, that could later lead to some kind of harm or liability. And then with negligence, right? Just all products that sort of companies put out there, they have some basic assumptions that there's not going to be, you know, the product won't be reckless. It won't cause harm in some reckless way. And there may be incidents with AI systems. I'm thinking in particular, you know, self-driving vehicles or drones, something like this, where they could cause some kind of reckless incident, and negligence, just general negligence sort of standards could kick in. Third parties is real quick and easy, so I'll spend 1 second there, and then we'll move on to the next slide. Third parties are all those different people, all the data vendors, all the different consultants, everyone that participated in the generation of this system. Are they all following the guidelines above, right? The previous 6 guidelines, is everyone involved in the model following those? And that can be a really hard question for these very large, complex models. So next slide. All right, so what can you do? You know, faced with all this, it may feel overwhelming. And there luckily are some things that you can do. And so this slide sort of lays out the outline, and then the next few slides kind of tackle it piece by piece. But we're big fans of interpretability, interpretable machine learning models, and sort of in the structured data world, it's an easier pitch, because in the structured data world, there's you know, all this work by Cynthia Rudin. There's the GA2M/EBM work coming out of Microsoft Research with Rich Caruana. And what this is complex, nonlinear models that consider high degree interactions implicitly, but they're also highly interpretable, right? So this idea that I have to trade off between interpretability and accuracy is at least the idea that it's a hard and fast trade-off that's kind of dying in the traditional structured data world. For NLP, I think we all know that these models need to be really complex to do what they're supposed to do, and it's a little bit harder to sell for interpretable models, but we'll talk about that more in a minute. There's still lots of options for sort of post hoc explainability, though, which could help make your black box a little bit more transparent. Once you have that interpretability or explainability, then you can debug your system, right? So we're proponents of interpretability because it's legally necessary in certain cases and just a good idea. But also why we really like it is it enables full debuggability. So interpretability enables debuggability. And then once you have these sort of two technical sort of pieces of groundwork in place, then you can do really good model governance, right? Then you can build processes around the interpretable model, around the debugging that you've done to help enforce sort of best practices and accountability. So we think interpretability enables debugging, and you can put governance on top of that, and that's how you start sort of getting control of some of this stuff. So next slide. All right. So what I put on the slide is I would argue an interpretable NLP model. It's a network graph of sparse topics that was extracted from a sort of sample text corpus. You know, it's not BERT, that's for sure, but there's lots of advantages even in this sort of complex black box world of modern day NLP. I'd argue there's still advantages for interpretable models. So, you know, sometimes you just get lucky even in these complex tasks. If they're extremely noisy, sometimes simpler models are just more accurate, right? So it might behoove you to at least try an interpretable model. And another reason to just try one is because you can always use them as a benchmark, right? You can use them as an interpretable benchmark to help you debug and help you build off of to improve. So you learn something about your data when you build the interpretable model. Then when you go to the black box, you might be able to bring some of that learning into the black box and make it better even. In my experience, customers love interpretable models. In one project I was involved in, you know, very similar to the one on the slide, you know, some of this network visuals were actually incorporated into the company's branding. So I mean, really, these interpretable models are almost like infographics, and you can get a really positive response from them from your customers in some cases. So also, you know, it says on the slide, but just in general, it helps answer those questions from the last slide. How is it working? Is it broken? You know, has it been hacked? Is it discriminatory? You know, you could possibly help your breach reporting if you understood how the model works. So we're big proponents of interpretability and explainability in machine learning. But we can go to the next slide. Okay. So remember we said interpretability, debugging, then governance. So this is the debugging slide. There are starting to be really high quality tools out there for debugging NLP models. And in fact, the checklist paper, that's actually being talked about at this conference. And you know, I'll let you read it or go to the talk on your own. But you know, the claim in the paper is that by following this sort of more enhanced debugging process, as opposed to just test data accuracy or test data quality, people are actually able to build better models. So checklist is sort of like a unit testing framework for NLP models, and the claim in the paper, which I believe from my own experience, is, you know, when you do this more sort of robust testing, you find more errors and your model gets better, right? So it's about preventing the negative and sort of increasing the positive. But again, two good tools for debugging NLP models specifically. Next slide. All right, so we talked about governance too, interpretability, debugging, governance. Here's a very interesting sort of example of governance for very complex AI systems. So Facebook and likely other companies take a practice from sort of more standard IT governance or software security and apply it to their AI system. You can do that. You can and should do things like testing, red teaming, bug bounties. You can do these things on your AI system, right? And Facebook does it. And so just in general, it's a good idea to take these best practices from regular software world and start applying them in AI software world. And this is just an example of that on the slide. And you know, Andrew and I both are interested in the security aspect here. So we do really like this idea of outsiders red teaming or sort of trying to attack and debug AI from the outside. So we can go on to the next slide. All right, so again, you know, this can feel overwhelming. Let's take a step back and just start talking about some basic stuff. So this is kind of some of the stuff that we tell our clients, and how do you operationalize this advice? So next slide. Number 1 point, don't wait. Okay. We'll talk about this more in the next slide, but complex systems fail. Okay, AI, machine learning are complex systems. Complex systems are known to fail. So you know, all models are wrong. Some models are useful. Your model's going to make a mistake. Don't wait flat-footed for that day to happen. We can move on to the next slide. So this is borrowed from some of our, and in particular Andrew's experience with the federal government. Just a basic way to think through AI risk, right? There's the instant, there's the boom that happens in the middle at T0, and then there's left of boom and right of boom. So we said don't wait, and what that means is that these T-2, T-1 before the AI incident occurs, what can you be doing? Well, you know, one of the biggest things you can be doing is thinking about things like AI principles for your company, model governance principles for your company. And then, you know, what we're suggesting in the slide is you can kind of move specifically, you know, once you have sort of these big buckets covered, you can start thinking about investigating models specifically and sort of governing specific AI systems within your organization. It's not if, but when with complex system failures. And you know, we've already gone over what the liabilities are. They're reprinted on the slide. We also do a certain degree of incident response and incident recovery, you know, helping people when the bad thing does happen. And one of the most important things there when the bad thing does happen is to have a response plan, right? And that's something we've advocated for. And I saw recently in a document from Boston Consulting Group where they were also advocating for having response plans for AI system failures. And if you do have that response plan, it makes the incident recovery much easier. So next slide, unless you'd like to add anything here.
Nope, go for it.
Okay. All right. And so, you know, again, kind of taking a deep breath, what are some simple things I can do today? So questions you can start asking in your organization. Who tracks the AI risk, right? Is it someone's job? It probably should be if you're doing a lot of work with AI, and just having an accountable person, an accountable executive can really go a long way to helping mitigate risk when that's someone's job. So you know, on this sort of idea of accountability, who's responsible for auditing systems before they're released, and after they're released, right? So hopefully that's not a nobody and a nobody at your organization, but that's not that uncommon either. And again, just having teams that are supposed to be doing these things can help a lot. And then finally, this on continuing on this theme of a AI incident response plan, right? Complex systems fail, airplanes have problems, nuclear reactors have problems, AI systems are going to have problems. So you need to have a plan ready for when that happens, and we do have a sample plan that we'll highlight in some of the coming slides. But moving on to the next slide. So these are you know, this slide is supposed to be good news, and we feel like it is good news, and this is sort of how we spend our days. There's a lot of technology that's being developed and currently available to help make AI more trustworthy. And so on the left, we have the technology, And on the right, we have some cultural steps. And of course, we don't have time to get into all of this now, but this is just to maybe put some keywords out there, allow you to do some Googling, and to allow you to feel better that there are both sort of technical and process solutions today, some of which we've highlighted in the presentation, some of which we didn't have time, that you can start putting in action today. So some good news there. All right, next slide. All right, so these are resources that Andrew and I have put together, and so the top one is 10 questions on AI risk, and these are patterned off questions that actually senators ask some health insurance companies in the wake of one of those discrimination scandals. And these are really high-level questions, great for data scientists to be able to answer, but they're really designed for sort of executive and board level type decision makers. So please check out the 10 questions on AI risk. Really simple and we hope effective kind of risk mitigation questions. Also, the sample AI incident response plan or checklist. We're hosting that on our GitHub under an open source license and hopes to sort of kind of spawn community interest in this topic that we think is really important. I've become fond of saying, you can't buy a microwave without a troubleshooting guide, but I can spend $10 million on an AI system and yet have no one know what to do when something goes wrong with it. So that just makes no sense. And this link that we have here will take you to an example AI incident response plan so that you can start thinking through maybe tabletopping what you would do when an AI system fails. Speaking of AI system fails, that's the next link there. This is a sort of shorter article, much shorter than the sample checklist that you could just read through and kind of get some of the basics of our thinking on what to do when AI fails. And then the bottom link is a white paper that we did a little while back with the Future of Privacy Forum talking about some of those different AI attacks, right? And we definitely feel that machine learning security is sort of a blind spot for both traditional IT security and model risk management. Neither one of those fields, which are doing a great job today mitigating AI risk, the machine learning security stuff is so new that's a little bit of a blind spot for both of them. So if you have concerns there, feel free to check out that bottom white paper. Next slide. All right, so these are just some resources that I've found to be helpful for debugging specifically NLP models. Likely many of you watching right now would know more about this than I would, so I'm not going to focus here. I just want people to make sure people are aware of these. So we'll pause for a second so people can see them. And next slide. So there's a lot of really good regulatory resources out there already. And it's likely that future regulation will either be based on some of these links or be patterned after some of these links. And I find these links really helpful for just mitigating risk in my own work. I mean, some of them are really masterful treatises on AI risk. So Andrew and I love to point clients towards these, and hopefully you'll find them helpful too. And we can move on to the next one unless you want to. Okay, and this is us. So I think the way this is going to work is we'll be around to chat and answer some questions, but please feel free to reach out to us by email as well. This is our life. We live and breathe this stuff, and we really like to help people with these problems. So this is how you get in touch with us if you'd like to do that. And thank you so much for your time today.
Thank you.